Good day everyone. Welcome to Teacher Julie channel. Hello everyone. We have our new lesson in Science 7, which is all about unveiling the unseen, scientists and their models. This will be the first quarter topic under Matatag curriculum. For the learning content, the use of models. For the learning standards, learners learn that scientists use models to explain the phenomena. And the learning competency, the learners recognize that scientists use models to explain phenomena that cannot be seen, easily seen, or detected. For the learning objectives, at the end of 45 minutes session, 80% of the students are able to first describe how scientists use models to explain phenomena that cannot be easily seen or detected. The second one is to perform a model analysis activity to explain phenomena that cannot be easily seen or detected. And the third one is to appreciate how scientists use models to explain phenomena that cannot easily be seen or detected by the use of model analysis activity. Under the Matatag curriculum, the first part of the lesson is to activate the prior knowledge of the students. So here, you begin the lesson by asking students what they understand by the term model, and the teacher will elicit responses and write the key ideas on the board. Afterwards, the teacher will ask students to share examples of models that they have encountered in their daily lives. After the students will share the examples of model that they have encountered, another question will be asked to the students. How this model help represent and explain the real-world objects or phenomena. After the teacher elicit response to the students, the teacher will now explain what is a model. Models are simplified representation of complex real-world systems or processes, and models provide a tangible way for scientists and students to visualize and conceptualize things that are too small or too large, too complex, or too distant to observe directly. The second part of the lesson under the Matatag curriculum is to establishing purpose of the lesson. So here, the teacher will ask another question to the students. Why it is important to learn how scientists use models? After the teacher elicit response to the students, she or he will explain to students that in this lesson, the students will describe how scientists use models to understand and explain things that are not easily observable. The teacher also will emphasize that models are important tools that help scientists make sense of the world around us. Another part of establishing purpose of the lesson is to unlock content of vocabulary. So here, we have the activity called the vocabulary matching. So students will match key vocabulary terms to their corresponding definition, reinforcing their understanding of the concepts. Invite students to come up one at a time and match a definition card to the appropriate vocabulary term. As each student makes a match, have them explain why they think that the definition matches the term. The third part of the lesson is the developing and deepening understanding. So here, you are going to discuss how each of these models helps scientists understand and explain the respective phenomena. At the heart of scientific inquiry lies the need to understand the world around us. So, from the vast expanse of the cosmos to intricate workings of the smallest building blocks of matter. However, many of the phenomena that shape our universe are not easily observed or detected with the naked eye. So, this is where scientific models come into play. Scientific models are representation of real-world phenomena that cannot be easily seen or directly measured. This model serves as conceptual frameworks, allowing scientists to visualize, analyze, and make prediction about the underlying processes that govern the natural world. The following are the types of scientific models. The first one is the conceptual models. These are qualitative, abstract representations of a system or process. Conceptual models often use diagrams, flowcharts, or verbal description to convey the key components and relationships. Examples include the lock and key model of enzyme-substrate interaction or the food web model in ecology. Another types of scientific models is the mathematical model. So these models use mathematical equation, algorithm, and numerical simulation to represent and analyze a system. Mathematical models can be used to make predictions, test hypotheses, and optimize processes. Examples include the Lotka-Volterra equation for predator-prey dynamics or the Black-Scholes models for pricing financial options. Another types of scientific models is the physical models. These are tangible, scaled-down representation of a real-world system or object. Physical models can be used to study the behavior and properties of a system in a controlled environment. Examples include the tunnel models for studying aerodynamics or scale models for building of architectural design. Another types of scientific models is the computational models. So these are computer-based simulations that use complex algorithm and numerical methods to model the behavior of a system. Computational models can incorporate mathematical equations, empirical data, and theoretical principles to make prediction and test hypotheses. Examples include the climate models for studying global weather patterns or agent-based models for simulating social and economic systems. The last type of scientific model is the hybrid models. So these models combine two or more of the above approaches, integrating different types of representation and techniques. Hybrid models can leverage the strength of various modeling approaches to provide a more comprehensive and accurate representation of a system. Examples include the coupled climate economic models that incorporate both mathematical and computational components. One of the most well-known examples of scientific model is the solar system or the solar system model. So this model predicts the arrangement of the planets, moons, and other celestial bodies that orbit the sun. By studying this model, scientists can better understand the gravitational forces at work, the movement of the planets, and the overall structure of our solar system. This knowledge, in turn, helps us make sense of the larger scale dynamics of the universe. Another example is the DNA model, which represents the double helix structure of the genetic material that carries the instructions for life. This model has been instrumental in unraveling the mechanisms of inheritance, gene expressions, and the fundamental building blocks of living organisms. By studying this model, scientists have gained invaluable insights into the mechanisms of life, paving the way for advancement in fields such as genetics, medicine, and biotechnology. Another example is the weather forecast models. So, this complex mathematical representation of atmospheric processes and patterns help meteorologists predict the weather by simulating the interaction between various factors such as temperature, pressure, and moisture. While weather forecasting is not an exact science, this model have become increasingly accurate, enable us to better prepare for and respond to changing weather conditions. In each of these examples, the scientific models serve as a powerful tools for understanding and explaining the underlying phenomena that shape our world. So by simplifying and abstracting the complex realities of the natural world, these models allow scientists to test the hypothesis, make the predictions, and ultimately deepen our knowledge of the universe we inhabit. It is important to recognize that scientific models are not perfect representations of reality. They are simplifications that aim to capture the essential features of a given phenomenon. As our understanding of the world evolves, these models are often refined, updated, or even replaced by more accurate and comprehensive representation. This iterative process is a hallmark of scientific progress as we continuously strive to better understand the intricacies of the physical, biological, and environmental systems that govern our existence. The fourth part of the lesson is making generalization. So here, the students will make model analysis activity. And the last part of the lesson is evaluating the learner. So here, I'm going to use multiple choice for the evaluation part.